Hey everyone, and welcome back. Following our previous video, which is about how to generate network device configurations for Cisco routers and switches, we have learned how to do this from a basic level point of view. For those who haven't watched the video, I have left the link in the description below. In today's video, we will dive deeper in this subject by showing you how to build the inventory file and understand the reason behind grouping our configuration variables based on technology, device type, and the location. We will also going to use the default and inheritance values to do some configuration manipulation. Then we will show you how you can simplify your script by modularizing your code to make it more efficient and optimized. Finally, we will show you how you can use multithreading in the event that you want to generate configs and push them to the end devices at the same time. Okay, to put this into context, let's imagine that the company you work for has multiple products and services that they can offer to their customers. For example, they can offer the services you see on the screen. We can see Ethernet, DSL, wireless, LAN, and security services. Each technology will have its own service catalog. For example, in the Ethernet technology, we can see that there are WAN and Internet service catalogs. The same applies for the DSL technology, so on and so forth. And then each service catalog will have a bespoke configuration. And then we have different device types and models for each service catalog, as you can see on the screen. Not to mention that if the company you work for is operating across the globe, you might want to use different configurations for each location. So what we have learned so far is how to create a host variable file for each device in order to generate configs. This solution is perfect if you have a few devices to manage. But in the real world, you will probably manage many devices, say, for example, a few hundreds or even a few thousands devices. So because of this, we need to define a new way to generate configs that is scalable and efficient. For example, if we imagine that we want to configure DNS across all of our devices, and let's say that we have 300 devices that we are managing, and we have 100 devices in Africa, 100 devices in Europe, and 100 devices in Asia. And let's say that we want to configure each site with different DNS IPs. So let's say devices in Asia would have DNS IP of 8.8.8.8, whereas devices in Europe are going to be configured with 8.8.4.4, and finally with Africa will be 1.1.1.1. So what we don't want to do is to go through each host variable file and define those options. It's just simply not efficient and not scalable. Instead, we could section out our network and create groups based on technology type, location, and device model. So if we have three files for the example I mentioned earlier, where each group represents each location, we could ultimately modify the file to add those DNS IP configurations, and all the 300 devices will be updated accordingly. This is the power of well-thought design to scale and manage your network configuration pool. So our current topology is not the biggest, but this will show you the method to scale your automation methodically and efficiently. As you can see on the screen, we have three routers in our lab. Each router is located in a different location, and each router is connected to each location. I've also included the model of each router and the interface ID, so please do take a snapshot if you want so that you can follow along when I build the inventory file. So before we crack on with coding, I just wanted to show you how the project will be structured so that you can then take this example and use your own imagination and use it as a foundation of something that you are able to adapt moving forward. We will build a folder for the base config, and inside that folder, we will have the skeleton host variables for each of our devices. We will also create a folder for group location, where if we want to add certain configurations to certain locations, this will enable us to do so. we will also build a group model for each of our devices to apply unique configurations for each hardware specific. And then we will also build our inventory management file, where we created this before in our previous video, but today we will add a couple of more fields in the file. I will show you that in a minute. And then we will create a folder for group technology where we specify the type of technology, for example, DSL or Ethernet, as we discussed earlier. Then we will create the template in Jinja2 format. Again, we have explained this in the last video. And finally, we will build our code by using PyYAML and Jinja2 libraries. So without further ado, I'll crack on with the demo. Okay, so I created a new project using my IDE application. And for quickness sake and to avoid boring you with admin work, I filled the data in the background and I will walk you through what I have created so far. So I did create multiple folders, as you can see on the screen from the left-hand side. So in the base config folder, I created 4 files. So if I open the default.yaml file, here we see that we are going to use the config that we want to use against every device on our network. So I've created a variable called banner, and I've assigned that a default value of this is the default banner. And if we were to open the router-a.yaml, we can see that we have our variables already been configured, much like what we did previously. So I'm not going through it again. And the same applies for router B and router C. Under the group location, I have created multiple files for each location as discussed earlier. And if I were to open each file to show you what's inside, you will see that I have added a variable called the DNS variable, and that represents each site as we discussed earlier as well. So in africa.yaml file, I have configured a DNS variable with 1.1.1.1, whereas in Asia, is 8.8.8.8, and finally Europe is 8.8.4.4. Under the group model, I have created multiple files for each of the device model I have in my lab. So if I open the ASR920.yaml file, we can see that I have created a banner variable and I have assigned that variable the string you see on the screen. And the same applies for the Cisco 877. And you can see that this time I'm using variable called test, and I haven't included the banner. And I will explain that in a minute, why I've done that, because I wanted to show you a special use case for this purpose. And then finally, for the group model folder, we have the Cisco 1117.yaml. And again, you can see the banner is on the screen. So under the group technology, I have created multiple files. Each file represents each technology that I have. And if I were to open the DSL.yaml, you can see that I have created a dummy config that present the type of technology where we will only apply it if the device belongs to the DS technology. Similarly, with Ethernet.yaml, I have created again a dummy data that present Ethernet configurations only. And then finally, under the templates folder, I have created 3 different Jinja templates files. If I were to open the ASR920, you can see here that this is the configurations that I am going to generate by using Jinja2 templates. So the configuration starts with service space password encryption, the host name, and you can see that the variable that I'm using is inside this command. And I also, in the previous video, I went through this section with you. I also included the SNMP, much like what we did in our previous video. And what I have done this time, I have added the following section. So here under banner, MOTD, I have added the variable called banner. And under IP namespace server command, I have added the DNS as well. So that will be dynamically configured. And then finally, I have also included the technology section where we are going to produce the configurations that we want for based on our technology specific type. Okay, so what I'm going to do next, I'm going to show you what I have configured under the inventory file. So if I go in and open up my inventory.py file, I have created a variable, and that variable I have assigned it to an empty list. And inside that list, I have created multiple dictionaries. Each dictionary have keys and values, and each dictionary contains information or inventory information regarding my devices. So what you see on the screen here, for instance, the host name has a value of router-a. The host is assigned to the IP address. The username is admin. The password is Cisco123. The same for secret. The device type, Cisco_ICE. We have seen this before. And what I have added to this inventory list is three more keys. So we have the technology underscore groups, we have the location underscore groups, and we have the model. So under technology, I'm specifically assigning the Ethernet for this particular host. However, under location underscore groups, I have assigned a list. The reason why we are assigning a list is because we might have multiple locations and you want to be even more specific about the locations. So hence why we can have multiple elements within the list. So if you want to have Europe, and then the next element would be in the UK, for instance, and then the next element would be in London, and that might vary between this device and this device, for instance, whereas this device will be again in Europe, in the UK, and this time it might be in Cambridge, so on and so forth. You get the message. And then the last key that I've also added is the model underscore groups, where we are specifying the model or the PID for the device in question. And the same methodology being applied for router B and finally router C. The difference between them is that we have different IP addresses, we have the same credentials, the same device type, etc., etc. However, the technology type this time is similar, but is located in Asia, and the model group is different to what we see for router A. And finally, the router C similarly have similar attributes, and under the technology group, we have assigned it DSL. And in terms of location underscore groups, we have assigned it to Africa. And finally, the model group is Cisco 877. So without further ado, what I'm going to do next, I'm going to show you how you can then build the code so that you are able to generate this config dynamically. You can take this and adopt it and then build upon this foundation based on your use case. Okay, so what I'm going to do next, I'm going to open up my file, my empty file that is called config_gen_advanced.py. I'm going to open this file. And what I'm going to do, I'm going to import all the libraries that I want to use for my code. And I'm going to start with importing the YAML. And also I'm going to say from netnewco, I want to import connect handler. I'm also going to import Jinja2. So I'm going to say from Jinja2 import environment, and I also want to import file system loader. And also I'm going to say from inventory, we want to import inventory. And what I want to do, or what I want to include as well, is I'm going to say from rich import print as r_print. So I'm going to also include from concurrent for futures, I want to import thread executor. And then finally, I'm going to import the time because I want to time how long the script will take when we push the configurations across multiple devices. So what I'm going to do first, I'm going to create the main function for the code, and I'm going to call it first. And I am going to create it by saying diff space main. And in here, I am going to say for each device in inventory, we want to print each device. The key for each device that I'm looking for is host name. Again, if you want to double check what is the host name is here, and you can see that this represents the value of router-b. So if I go back to my code, what we should be getting here is the host name. So I will execute this, and you can see that on the screen here, the result. So we have router A, router B, and router C. Great. What we can then do is we can create a custom function, and that function, I'm going to call it function underscore load underscore variables. And in here, we are going to then pass the device attributes. So the first step that we are doing is creating an empty dictionary, and that dictionary, we're going to call it data, and we're going to assign it an empty dictionary, and we're going to use it in a minute. And the first step that we want to do is retrieve all the variables from the default.yaml file. And to do this is very simple. What we need to do is we need to create, again, a variable, and I'm going to call that variable default underscore data, and we're going to assign it to yaml.safe underscore load, and we are going to open up the file in question. The file that we're looking for is the default.yaml under base config. So I'm going to specify the name of the folder. It's with a capital B. So I'm going to say base config, and then I want to include the default.yaml file. So at this point, we are able then to extract the information that we get from the default underscore data, and the data type that we get from this variable is dictionary. So to extract the information from a dictionary, what we need to do, we can say something like for each underscore key and each underscore value in default or data, and then dot items. And then at this point, we will be able to print the key as well as the value. So what I'm going to do, I'm going to print each key as well as each value. And in here, what I need to do is I need to call the method, which is function underscore load underscore variables, by saying function underscore load underscore variables, and I'm going to assign the parameter for each device. So it's going to be each underscore device. And I'm going to comment line number 24. So at this stage, what we can do, we can execute the script, and we will be able to see all the variables that is related to default.yaml. And watch this out. So you can see here that we have banner. This is the default banner. So we have this is the key, and the value is here. So at this point, what we can do, we can then assign this data into our data dictionary by saying data and then open square bracket, close square bracket, and say each key. And I'm going to assign for each key, I'm going to assign each value. And then at this point, what I can do, I can then comment line number 14. And then after the for loop, what I can do, I can then print the data dictionary. And if I execute this, you will see that we have the key banner and the value for it as this is the default banner. So this dictionary holds the information that we need from the default.yaml. And this is the first step that we need to do in order for us to build all the variables that are associated to our host variables from all the different files that we have already configured. So that is the first step. And then the next step, what we need to do is we need to retrieve all the variables from the host variables.yaml. So what I'm going to do, I'm going to create a local variable, and I'm going to call it host underscore data, and that is going to be equal to yaml dot safe underscore load, and in here I'm going to say open, and then I'm going to specify the if value front of the quotes so that I can add a string, and I'm going to say base config / open and close curly bracket, and I'm going to specify the device hostname by saying something like this. And also we need to specify the file extension. And then what we can do, we can say for each key and each value in host underscore data dot items. Oops. What we need to do, we need to print each key and each value. And if I then separate these two codes or these two sections with something like this, we will be able to see the difference. Right, sorry, I have missed an S. And if I execute this again, and you will be able to see here, we have the following data variables that we have retrieved from the file. And the same applies for host router B, and finally host router C. So one of the use cases that I want to show you guys is what happens if that file, a file that we come across, doesn't have any data. So let's just remove this data for now and go back to the script and then execute that again. You will see that there is an exception where it indicates that the input data or the default underscore data doesn't actually have any data and is expecting to see or expecting to find a key and a value, and it can't find that. So what we can do, we can put a condition in place where we say if default underscore data is not none, and I would say and default underscore data. And at this point, what we need to do, we need to indent our code so that it's inside this section. And here what we're saying, if the data default underscore data is equal to none, or if it has some data in it, then I need to execute this section pretty much. So if I were then to go ahead and execute that again, we should be able to receive the data we want, and we shouldn't have any exceptions. And we need to apply the same method on the second section, and I'm going to also move that section to be inside the if condition statement. And what I'm going to do, I'm going to go back to my default.yaml and I will revert my changes. And then we have the power to actually append the data dictionary to add the variables that are associated with default.yaml, as well as the router a.yaml and the router b.yaml and the router c.yaml. So what we're going to do next is we're going to say data, and I'm going to specify the key, and I'm going to assign each value variable, and I'm going to comment line number 23. And after this section, what I'm going to do, I'm going to print the data dictionary. And if I go ahead and execute this, so as you can see on the screen here, so the first iteration of the data variable, we get the banner from the default.yaml file and the value, which is this is the default banner. And then the second iteration, we managed to append the data dictionary by adding the host name, the interfaces, so on and so forth. And if I were to use our print so that you can see it in more details, in one page, if I scroll all the way up, you can see that the first time the dictionary has been printed, and then the second time you can see the information or the data has been appended to the dictionary. And this is the ultimate goal, what we're trying to do and achieve at this stage, because we want to collect all our variables into one dictionary such that we can then push this data into a template so that we can then generate our configurations. So I will go through this quickly. So we have an outer key, which is interfaces, and inside that we have a list of interfaces. You have the first dictionary, interface loopback one, with the corresponding interface description, the corresponding IP address, so on and so forth. And we also have the SNMP for our SNMP communities, 1, 2, 3, 4, so on and so forth. And the same applies for router B. And finally, the same applies for router C. We have the list of interfaces and the list of SNMP. Great. So far, so good. And then what we are going to do next, we're going to tackle the technology. So we're gonna follow the same method again and again and again until we reach the end of our folders. And then at this point, we've managed to generate all our data, and then we will be able to then generate the configurations. So what I'm going to do next, I'm going to actually copy that section and I'm going to paste it here just for quickness. And instead of using the base config, I am going to use the group technology. And instead of using the host name, what we need to do, we need to use the technology underscore group. So I copy the key from here, I go back to my code, and I paste that in here. And basically, I just need to change the local variable. That is not really essential, but I'm going to just change it so that it makes sense to the reader. And I would say underscore data, and then I would need to replace all these variables. And what we see on the screen here is pretty much it, really. So I want to actually print the key and the value before we actually go ahead and assign the data, just to make sure that our code is working as expected and that we are not hitting any issues. So I'm going to execute that. And then you can see at the bottom here that we have the technology being printed by this section here. And we see here the technology type is DSL, interfaces loopback 999, interface description, etc., etc., as you can see on the screen. So at this point, what we can do is we can then assign it to the data dictionary that we've created earlier. And then what I can do next is I don't want to print this one, but I can print this line. And if I execute this again and scroll all the way up, so you see, this is the first time that we print our dictionary after the default.yaml, and then the second iteration is loading the router a.yaml, and then the third iteration is appending the file once more to add the technology bit. So we see the banner, we see the host name variable, the interfaces, as well as the SNMP, and then you can see the technology also has been added as part of the dictionary, and so on and so forth. You can see that this has been applied for router B as well. So if I scroll down, you can see the technology section has been added. And for finally router C, the technology section is also being added accordingly. So what I can do next is I can, again, copy that section and we can tackle the group location. So instead of using group and group technology, we can say location. And because we are using the location, then we would need to use this location underscore groups key from our inventory. And then I'm going to paste that in there. And again, I'm going to change the variable to location underscore data. And then I'm going to update associated variables. Again, I will do the same thing. I will print the key and value first before I actually print anything else, and make sure that the code is working as expected. And then I'm going to execute this, and we have an issue. Right, okay. And the issue is that we have actually got a list instead of a string. So what we will need to do is we will need to include that as part of a loop. So if I say for each, let's say, location in device, and then open square brackets, close square brackets, location underscore groups, what we can do, we can then indent that section to be inside that for loop. And then what we can do, we can take this element and paste it in here. I think that would do the trick. And if I then go ahead and execute this, you can see that we have managed to get or print the DNS for each of our location files. So if I scroll all the way up, you can see that the first router has a banner of this. And then you can see that the DNS that we're printing that is associated with router A comes with 8.8.4.4. The second router, router B, which is associated with DNS 8.8.8.8. And then finally, the last router, which I believe is in Africa, is associated with 1.1.1.1. Great. So at this point, what we can do, we can then add or append our dictionary to actually include this data. And what I will do, I will then remove this section so that we don't have a lot of code unnecessarily. And then I will execute this again. And then if I scroll all the way up, you can see that this time we have got the banner from the default.yaml. We also have the host name and all the interfaces from the router-a.yaml. And then we have the technology section from the technology.yaml. In that case, it will be Ethernet or DSL. And finally, we have the DNS as well. So we've managed to collect all this data from a single function. So what we would do next, so we've managed to tackle the base config. We've also tackled the group technology. We've tackled the group location. And then the last iteration is going to be the group model. And what I will do, again, I will copy this section and I will paste it here. I will comment this line. And in here, I'm going to change the directory into model. And again, I'm going to just check what I have actually configured the key with in my inventory. And then I will copy it and I'll paste it in here. And finally, I will just change the local variable to model underscore data. And then copy this variable across. I'll do the same thing. I'll just print the key and the value. And just to make sure that everything is working as expected, I will execute this. And you can see, guys, here again, we have the banner. This is an ASR 920 model for the first router. You see, this is for the second router, and then the third router is test. This is a test variable, as you can see on the screen here. Great. So what I'm going to do next, I'm going to actually append the dictionary file. And again, I will comment line number 42, and I will take this line and I will copy it over here. And at this point, guys, we should be able to have all the data that we need so that we can then go ahead and push this data into a template. So I'm going to execute this and then I will just walk you through it one more time. So we have the first router, router A. We have the list of interfaces. We have the SNMP. We have the technology as well as the DNS. And also we have the banner, and the banner is this one. So one of the things that I wanted to show you guys is that the banner is already in the default configurations or in the default .yaml file. And the reason being is because if you wanted to include a default configuration for your network devices, you can do that. And then further down the line, you can then overwrite this configuration to be more specific. As you can see, as part of the router A, we have already overwritten the default value. So the banner in that case has been replaced from this one to be more specific to this one. And we have done it mainly for router-A as well as router-C. Let's examine what happens with router-B because we haven't specified this. So if I go to router-B, sorry, we haven't specified that for router-C. So if I go all the way down, you can see that this is the default banner and the host name is router-C, which obviously that it's showing you a specific use case if you want to actually perform some sort of inheritance whereby you want to include only certain configurations for specific devices. You have the power to do that. So at this point, we've managed to gather all the information we need. And then what we can do, we can then, at this point, we can then return that data back to the main function. So I would say return data. And then that function is good to go. So I would just tidy up. And then what I will do here, I will say data underscore config equal to this. And then what I can do, I can say r underscore print data underscore config. So we should be able to actually get the same results. And as you can see, we get the same result here, pretty much. So that's the first step by creating a function, a custom function that allows you to actually retrieve all the data variables from all our host files. Next, what we are going to do, we are going to create another custom function where we are saying, for instance, function underscore generate config. And what we are going to do, we are going to pass the dictionary that has all the host variables in it, as well as the each underscore device. And what we are going to do here, we are going to copy this and we are going to create it here. So we're going to say function underscore generate underscore config, and we are going to pass the data. And we are going to say here device. And these names can be anything really, it doesn't really matter. And what we are going to do first is we are going to say env underscore object, and we're going to assign this to an environment. And inside the environment, we're going to say loader equal to file system loader, and we are going to specify where exactly to look for the templates. So we're going to say quotes and specify the templates folder. And also I'm going to say trim underscore blocks equal true, and the L underscore or L strip underscore blocks also equal to true. Next, I'm going to create an object called template, underscore object or OPG, and I'm going to assign that to an env underscore object dot get template, and then we are going to specify the template name by specifying the model of the device in question. So in that case, we are going to say device and then open square brackets, close square brackets, and inside there we are going to specify the model group model. And actually, to be more precise, I need to go back to my inventory, and then we need to copy this key. Now we're going to paste it here, and we also we mustn't forget the J2 extension file. We can then say device underscore configuration will be equal to template underscore object dot render, and then we are going to say I want to actually pass the data that we have just created. And at this point, we should be able to actually print our device underscore configurations. This is how we can then generate the configurations in question. So if I then go ahead and if I created everything correctly, then we should be able to actually generate the config. And if I go all the way up, so you can see this is the config that we have generated. So it comes with service password encryption, the host name is router A, all the interfaces that includes the physical as well as the virtual interfaces. We also included the SNMP community, and you can see that the banner MOTD is quite specific to the one that we want. We have the DNS server with 8.8.8.4.4 and then this interface has been is configured based on the Ethernet technology type, and this is pretty much printing the dictionary. And then if we scroll down, you can see the same applies for router B. Again, list of interfaces, the SNMP config, and then the MOTD. The DNS server as well, 8.8.8.8. And then finally, the technology type for that device is Ethernet as well. And then the last configurations that we see here is related to router C. And in here, we can see loopback 1, interface, physical, virtual interface, as well as the physical interfaces. The same applies for SNMP. The banner is the default banner this time. You can see that the default banner is being triggered. The DNS configuration has been populated again according to what we want it to be. And again, the DSL configurations have been applied as we expected. And as you can see on the screen. And then what we need to do next is I am going to actually not print this. And what I will do next, I am going to say I want to return device underscore configurations dot split lines. And in here, what we would say device underscore configuration equal to this method or this function. And then what we can do, we can then say print device underscore configurations. This way is you will get it based on a list. And once we have that list, then we are able to then invoke netmiko so that we can then push this configuration to the end device. So what I will do next, I will actually create a custom function, and I'm going to call that function underscore send underscore config underscore to end devices or device. And in here, we are going to, again, we want to send the device configurations as well as the device attributes. So what I'm going to do next, I'm going to create this function, and I would say diff space this. And here I can just, to be kind of like quite precise, I'm going to say device. And in here, we are going to say with connect handler. And in here, we are going to specify the parameters for connect handler, such as the host, the user credentials, and the secret, as well as the port and what the device type, etc., etc. So I'm going to say device underscore type equal to device, and here we are going to say device underscore type, and then we are going to specify the host as well. And for quickness, I'll just copy this across multiple times. then username equal to this, password is equal to this, and then secret, this is optional, but I'm going to include it anyway. And then finally the port, which is going to be equal to that, and then I would need to change that to host. This is the username, this is the password, that one to secret, and finally this one to port. And we're going to say as net underscore connect. And in here, what we're going to do, we are just going to, I just want to print underscore connect dot find prompt. Just want to make sure that this will work with no issues first, and then after that we will be able to then push the configurations. So I'm going to execute this, and of course we haven't actually, so secrets, yes, secrets, so secrets looks like is not the same as what we've got here. So let me try this. Oh yeah, secrets. Secrets has an S, which is, it should be secret rather than secrets. So I'm going to execute that again. And we can see that we've managed to log into router A and router B and router C. And what we can do next is I can show you if I log into my devices. So bear with me 1 second. So you can see on my screen here, so if I say show IP interface brief, you can see that router A doesn't have any loop interface and doesn't have any gig Ethernet that is configured apart from 01. The same applies for router B. I don't have any loopback interfaces, and the only interface that is configured is gig Ethernet 02. And again, the same applies for router C. The only interface that is configured is 03. So what happens then if we go ahead and execute this or push the configuration? So what I would do here, I would say something like, I want to see, I'm going to create a variable. That variable is going to print the output for the send config set command. And I would say local underscore output equal to net underscore connect. And I want to send config underscore set. And I'm going to specify the config underscore commands parameter, and I will pass the configurations that we just created. And what I will do, I will print the output accordingly. So I will then keep that or comment that. And then at this point, guys, we are ready to go. So I'll go ahead and execute this. So you can see that router A has been configured, and so is router B. And finally router C. So if I go back and say, for instance, show IP interface brief, you will see that Ethernet 00 has been configured and it's in the up state. The same applies for gig Ethernet 02. And a couple of loopback interfaces have been created for router C. That is loopback 999, which is associated to DSL technology. And if I go to router B, you can see that more interfaces have been configured. And the same applies for router A. If I then say show run pipe include DNS or server, you can see that we have the DNS configurations. So router A has 8.8.4.4 and the SNMP community again. And if I go to router B, you can see router B has been configured with 8.8.8.8, again with the associated SNMP community. And finally, the router C as well. So what I will do next, I'm going to actually time how long the script actually has taken to configure 3 devices. And what I will do, I will replace my current configurations, and I would say configure replace nvram, and I'm going to specify the startup. Okay, so again, I will just say show run. So if I just hit enter to clear the screen, and if I issue the show run pipe include server, you will be able to see that I haven't got any SNMP config. Same applies for router B, and the same applies for router C. And if I say show IP interface brief, we can see that all the interfaces and all the configurations that I've just pushed has been removed. And then what I'll do, I'll go back to my code, and then I will also specify time. So at the beginning here, I'm going to say start equal time.time, and then at the bottom, I'm going to include this. Basically, this will work out how long the script has took to finish and to complete all tasks pretty much. So I'm going to execute that again. Okay, so the script has taken 21 seconds for only 3 devices. Can you imagine if you've got 100 devices or even a few thousand devices? Obviously, that will take a significant amount of time. So this is why I have added concurrency at the beginning here, if you remember. And what I will do, I'm going to utilize that now to show you the difference. But before I go ahead and do this, let me just go back to my devices, and if I then repeat the same commands, you can see that the config has been pushed. And if I do snmp, or sorry, show run pipe include server, you can see that the configuration has been pushed back again. So I'm going to go back to my code, and what I'll do, I'm going to say something like with thread pool executor, and as executor, I am going to say result equal to executor.map, and we are going to say I want to invoke the main function, and I'm going to pass the inventory file. And at this point, we will not need to actually go through a loop at this point, but what we need to do, we need to actually say, we would need to specify each device here. So I'm going to comment this line, and I'm going to fix the indentation for this block of code. And also, I'm going to remove this pulling the main function. And I think that's it. So if I then go ahead and go back to my devices, and I'm going to actually remove the configuration once more. So you can see pretty much all the config has been gone. And that's the same applies for router B and router C. So what I'll do next, I'm going to actually execute this and watch out how long this will take. Okay, so it's a big comparison between 21 seconds to 7.5 seconds, which is a huge difference if you've got a multitude of devices that you want to configure in at any given time. Okay guys, so before I end the video, I want to show you how you can then simplify the script by modularizing your code. So what I'm going to do, I'm going to actually create a new Python file, and I'm going to call it global functions, global underscore functions. And what I will do, I am going to actually copy all these functions, and I'm going to paste them in here in the global underscore functions.py. And what I will do, since these functions are using YAML, so I'm going to have to say import YAML. I'm also going to say from Jinja2, I want to import environment as well as file system loader, and the same applies for netmico. So I'm going to say from netmico, I want to import connect handler. That's it at this stage. And what I'm going to do next, I'm going to go back to my config underscore gen underscore advanced. I will delete the libraries that I don't use. So they are actually quite redundant. And then what I'm going to do, I'm going to say from global underscore function, I want to import function underscore load variables. I also want to include function underscore generate underscore config. And finally, I want to include the send config to the end device. So at this point, you can see that we have simplified our script massively. And what I can do, I can then go ahead and execute it. But before I go ahead and execute it, I just want to show you that right now I don't actually have any configurations. So if I say show IP interface brief, the only configurations that I've got is just for a single interface, and that is for router C. The same applies for router B and router A. And if I do the same thing, if I say show run pipe include SNMP, I will show you that I don't have SNMP community configured. And if I say show run pipe include server, you can see that I don't have any DNS configurations. And finally, what I'm going to do, I'm going to say show run pipe include MOTD. Great. So what I'm going to do, I'm going to go ahead and execute that script and see how it goes. Right, as you can see, we get similar results to what we have had a few moments ago. Okay, so if I go back to my devices, I can say, I want to say MOTD that is being configured, and you can see that this banner has been configured for router A. And if I actually copy this command and paste it there, you can see across router B as well as router C. And if I say show IP interface brief, you can see all the interfaces are associated with router A is configured. Same applies for router B, same applies for router C. And then finally, if I say show run pipe include server, we can see all the communities for SNMP as well as the DNS that is being configured for router C, router B, as well as router A. We have reached the end of the video. If you have found this video helpful, please don't forget to give it a thumbs up. And if you haven't already, please hit that subscribe button and turn on the notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop the comment below. I read all your comments and I'm here to assist you. Stay curious, stay inspired, and until next time, peace.